Hi guys, Mr. G here. We are going to look at this talk on equations for the next few minutes, and I'll be just looking at problems in particular, the kind of problems that you can expect. As an example, if I write down the equation here, say x minus 4 is equal to 10. Now, I'm sure you can already think up of a number, okay? A number, remember x means it really represents any number. So I'm sure you can think of any number here, of which if I subtract 4, I will get a 10. And at this point, really, I'm sure you have even thought about this. 14 is that number from which if I take 4, take away 4, that's what subtraction means, I will get 10, okay? So is there, what if then I have a number, a very bad number like 2.3794, okay? And I want to know how much should I take from this number, okay, to get something like 4.5. So what if I then get odd stuff like this? What if I get a decimal number and I've got to do that? Of course, you can simplify this a little bit and maybe try and multiply that by 10 or so that you make that easy, but that might even take you a lot of time. The point that I'm trying to bring here is that you will agree with me that it will be easier to solve this equation than that equation. So isn't there a formal way in which we can approach all equations? Okay, what you did here by finding that number is what we call inspection. Okay, by just looking at the equation and you're like, nah, I think I can just find that number. Okay, so there are formal ways in which we can actually solve equations. Okay, and that is what I want to bring out in this video. I want you guys to get this, understand this very thoroughly. For us to understand that, we must understand a number of things, or let's remind ourselves of a number of things. Let's talk about inverse operations. What are inverse operations? Well, if I have 2 and then I subtract 2, okay, or maybe let me start it this way. Suppose I have a certain number, x. X should represent just any number. And then I add 3 to this number x. For me to go back to that number x, or to get that number, I need to perform an inverse operation, minus, and then I must take away the exact same number that I added. So in the case of addition and subtraction, okay, what is happening here really is that these are inverse operations in a sense that one undoes what the other has done, and usually the result around that will be 0. Okay, as you can see, 3 minus 3 is 0. In a case where I have, let's suppose maybe I have x and I multiply this by 2. This is going to give me 2x. What should I do to go back to having an x, just a number x? Well, I must then divide by 2 so that I can have x. So we see here really that, well, multiplication has an inverse operation, which is division. But in this case, really, the result is usually 1. I want you to notice that. That is very critical in our discussion here. The result there is actually 1. Remember, any number, the invisible math, guys, okay, invisible math, x is actually 1 times x. The number 2 is actually what? 2 times 1, okay, but we don't just bother to write 1. Even the number x, we know in terms of fraction, it's still x over 1, but invisible math, we don't bother to write that 1, okay? So very, very important We need to understand this because when we deal with equations that involve fractions, we must remember these two inverse operations, and we must know that the goal is to make sure that the coefficient of x is 1. Here, when we deal with equations that do not have fractions and are just like that one we started with, we need to remember this too, that somehow I must get a 0 such that x is left alone on one side. Okay, and in some cases, guys, you're going to get equations that require you to use both these as methods or inverse operations. So let me take an example in which we use one inverse operation and a different inverse operation. So let's have an equation here. 2 plus x is equal to 16. Okay, let's call this worked example 1. Okay. So in this case, I want to have an equation or an answer. I want to arrive at an answer that says x is equal to something. And I'm sure by inspection, you have already picked that, come on, say that number should be 14. If I add 2 to 14, I'll get a 16. Yes, that's good. But now let's see, how do we actually use these operations? So I'm going to use an inverse operation here. I'm going to start by writing 2. And then I'm going to use an inverse operation and say minus 2, okay? And then I'm going to write plus x there is equal to, now, I know this is going to give me what? A 0. Remember, that's what happens if you take an inverse for addition or an inverse for subtraction, you know the result is 0. When you take any inverse for division or multiplication, the result, we want a 1. The aim is to get a 1, okay? Now, because there's an equation, guys, equal sign, it has to be balanced at all times, okay? So in this case, I have subtracted 2 on one side. To keep this equation balanced, I must also subtract a 2 on the other side. Otherwise, the equation is not going to be balanced. You can think of an equation as in case of a seesaw or a scale. Okay, if I put 2 kg here and I want this thing to be balanced, I must put 2 kg there. But now, suppose I just want to perform an operation. Say I want to add 1 kg here. If I add 1 kg here, this thing is going to be how? Okay, I'm sure you agree with me. It's going to go down here. So it's not going to be balanced. So I must add again a kg there. Okay, so that these two are always equal. So that is why I must do this thing, subtract minus 2, subtract 2 rather, on both sides. Okay, guys? So I hope you get that. So what should be x? Well, you realize that then, okay, this is 0. So that's very much done away with. So I have x here is equal to what? 14. I have used a formal way to actually figure out what the x value is, okay? And this is the approach that we would like you guys to use to just get you guys to solving equations, because we're gonna get really complicated equations later on, and you will need to use that approach. Finally, let me take another one here. Suppose I have one that says 2x equals to 16. So the same question goes again. In this case, I have a coefficient that is bigger than 1 for x here. So I know I'm going to use what? Division, okay? Because here what happened really, I multiplied 2 by x. So of course, you can go ahead and solve this by inspection and say, well, say 8 has to be x, okay? So let's see if that can be the case. So I must divide by 2 because I want the coefficient of x to be 1, okay? And so because there's an equation back to that seesaw, I must also have this here. And so this is going to be 16 divided by 2 is 8, okay? So you can see the idea, guys, behind these equations. So now, why am I bothering you with this? Because, guys, you're going to get really some complicated equations out there, And really, unless you have a strategy to solve them, you might struggle a little bit. Let me give you, for example, let me give you a nice one here. Suppose you have x plus 1 over 3 is equal to 2. You see, at this point, it might be a little bit tiring. It might tire your brain to try and solve this by inspection. So what you may really want to do again is to take that little advice of mine, use an additive inverse here. So here, you know, you're gonna say minus 1 over 3. And guys, because this is an equation, we don't want this thing to be unbalanced. So we're gonna balance it by making sure that whatever we did on the left-hand side, we are also going to do on the right-hand side, okay? That is very, very important. So this is x. We know this will always give us a 0. You may write the 0 if you like, really up to you at this point. And we're just gonna say, well, what is 2 minus 1 over 3? You can, of course, solve this fraction, but it will be quite nice if you know. Let me show you this shortcut quickly. Okay, if I want to figure out quickly what 2 minus 1 over 3 is, I know the denominator here is 1, but I want it to be 3. So I'm going to multiply by 3 over 3, okay? So then this becomes 6 over 3 minus 1 over 3. Then you know these are the nice fractions that you like. You're just going to have 6 minus 1 over 3. So you can see this answer here has to be 5 over 3. Otherwise, your calculator would have still come handy there. So yeah, 5 over 3 is our final answer for this problem. So what if then things get a little bit interesting? What if I've got now something like a fraction? So what if I have x over 3 is equal to 2? What do I do in this case? Previously, I mean, we had a very simple example, 2x equals to 16. You divided by 2, and then that was it. That was simple. But what about something like this? Well, guys, here we must think of what we call the LCD, okay? Here we've got a fraction. So what is the LCD between these two fractions? Remember, the denominator here is 1. So what is the LCD between 3 and 1? You agree with me, it is 3. So what you're gonna do, you are actually going to multiply by the LCD. So you're going to take your x over 3 there, and then you agreed with me that the LCD is 3. But remember, this is an equation. We have to keep it balanced. So I'm going to multiply by 3 also on the right-hand side, okay? And then I'm going to do this here. This is 3 over 1. So you can see this 3 will divide that 3, and I'm left with x, and this is 6. Now, in case you missed it, I want to go back a little bit so that no one misses this out. Check this. If I have x over 3 and I multiply that by 3, which is the same as 3 over 1, the right-hand side, I'm sure it's pretty easy. What is actually happening here, if you think about the rules that are there when we multiply fractions, we actually say you multiply numerator and numerator, denominator and denominator. So what is happening there, actually, you've got 3x over 3. And you know this, 3 divided by 3 is what? Is 1. That's why we are just left with x, okay? I hope you guys got that in case you had missed it. So these are the basic 2 types of equations that you can come across, but I can promise you there'll be more nice equations that are a bit complicated, and they will require you, I repeat, to use maybe more than 1 method, 2 methods, or 3 methods. Some equations will ask you to use the will require you to actually to use the distributive property, stuff like that. So guys, just to make sure you are on the lookout for that. I hope you have found this video to be very helpful. Share it with a friend, your classmate or so, and hit that like button and subscribe button on our YouTube channel. Thank you guys. Cheers.